And you might have heard it earlier, told you by Dave Scott, that Zen is a hypervisor, that means for virtualization, platform for virtualization, and it has been developed by Zen Source and was then acquired by Citrix. Originally, it was meant to do server virtualization, and that's what it's still doing, and we're selling it in Zen Server. But 3 years ago, 2009, people, like all people who have too many hammers and then see everything is a nail, looked for more applications of virtualization, and that was putting the Zen hypervisor on the laptop. And it turned out that it actually makes sense. There's actually some upsides to it. So some of the upsides are similar to what you get when you put it to the server, the hypervisor. So you can, it's easier to provision your virtual machines. That means you get the updates out for all your Windows VMs easily. You can scale up and down. The scaling doesn't really work on the laptop because you only have one laptop and you have to buy new laptops. But what also is more interesting on the laptop than on the server is enhanced security, because normally you don't, you do control physical access to your servers, or at least you trust the people who do in the data center, but the laptop is just lying around. And we can use the trusted computing module, the trusted computing module to make the virtual machines and the underlying system tamper-proof. So,
we've had 3 different operating systems. Oh, there we go.
So, like I said, Biology puts a cloud on your laptop, and basically it makes provisioning easier, so putting your VMs on the laptop, it makes administration easier. For the poor people who have to administer, you can get enhanced security, and basically for free you can still use your Windows, but have much better security than you have. Also, with security, there's one thing that is a natural tension often between like the admin and the actual users of the system. The users want to do stuff with their computer, but the admin actually want to have very well-defined stuff that you can do with your computer. So we can just give them 2 VMs, one for their personal MP3s, and they play whatever they want, and then click on their attachments in the email, and one lockdown VM where they can only do exactly what the admin wants. So in the personal VMs, you can even get admin rights without the admin, the real admin to get a heart attack. The next thing is it works offline because you can get similar benefits by just using like Zen desktops. That's our product to do remote computing, where basically all the VMs get run on a server, and you just have use your local hardware as a CenClient. So we're actually using the local hardware. And that also makes, as opposed to remote computing, makes latency much better, so it doesn't suck as much. Because to be honest, the virtualization for the user is not as fast, sucks a bit compared to native. We just try to make it better, but it's basically native is the thing we want to reach. So who actually wants that stuff? We're not really selling to customers, even so you can download it and try it out. It's mostly useful for corporate users because they have the app, or governments, especially shady military organizations, because if you read their their regulations and actually follow them, you would need 3 different computers, because they have like public, secret, and top secret. And like a monad, you can wrap something in more secrecy, but it's only very regulated to get out in less secrecy. It's actually sometimes needed. You can't just forbid it completely. And if you let the users do that, like polish them themselves, they will probably make mistakes. Yeah, a bit about Citrix. Probably heard about it. Citrix itself was founded in 1989. Has now 6,000 employees, of course, had less back then. XenSource, which made the virtualization, was founded at the computer lab, or spun off of the computer lab of Cambridge University. 2003, that's the first release of Zen. I think it was called Zen Express or something before. And Citrix worked together with XenSource because Citrix had this remote desktop solution, and they didn't want to rely completely on VMware because VMware was first in the x86 virtualization space. And so it made sense for them to acquire XenSource. Of course, otherwise it wouldn't be here, XenSource acted as a Trojan horse and brought in functional programming, which was OpenCL. Using OpenCL got started even back then at university. In 2009, we started XenClient. That was basically started by people who worked on Zen server before. Started by 2, and then it grew and grew. We now have around 30 developers, and of course, sales people and support. And most of the developers are in Cambridge, UK, as are the Zen server people who just across the hallway. Yeah. XenClient basically started off copying the code base from Zen server. That's why we used lots of OCaml at first, but we grew to implement other language, to put other languages into the product. Yeah, the expert is sitting over there. You can ask him for more details about Zen server if you're really interested in that. Yeah. Okay. So the architecture of the hypervisor, in the case of XenClient, works basically like this. Is a type 1 hypervisor. That means we have on top, basically that's the operating system. Then we have Zen underneath, and then the hardware underneath. This means whenever the operating system want to do anything with the hardware, they go via Zen, unless they have special pass-through. And Zen is actually doesn't do very much itself. It asks a specific VM called the .0 most of the time to do most of the debug drivers and other stuff that allows us to not have to implement our own debug drivers and just reuse the Linux ones. So Zen server is mostly a monolithic OCaml, but in XenClient we decided to break it up into small daemons that will bring benefits that I will explain later on. We have to be embedded, very reliable, because the user is not meant to interact with this directly. So the user shouldn't even know that there are different programs running underneath. It just is happily running as VMs. So that makes something that doesn't crash very useful. So for the languages, for us, the most interesting thing here is the Haskell bit. We also use OCaml, but that's basically leftover from Zen server, and that's quite stable, so we don't really do anything with the OCaml bits. They're just sitting there and doing what they're meant to do. That's stable. We start off having more OCaml, then yeah. So we started off having everything OCaml, but that was only like 2 people spinning. We grew the project, and we added people who didn't burn into OCaml into the project, and that introduced Ruby and other languages. The problem with the Ruby approach was that it was hard to make it bug-free. So like when you have bubbles in your carpet, trying to roll out some of the bugs, introduce new bugs somewhere else, and it didn't really work out. So over a weekend, Tomasz, one of our Haskell developers, or then to be Haskell developers, we wrote one of the major daemons in Haskell, and basically grew from there. Haskell, Zen Manager, is still our biggest daemon in Haskell. Zen Manager has around 10,000 lines of code, and we have around 25,000 lines of code all in all the Haskell daemons, plus libraries that the Haskell use, which is another few thousand lines of code. Yeah, why did we stick to OCaml later? So one thing was personal preference by the people who just did things back then. So the other thing was that why we kept using Haskell instead of OCaml is we have more libraries, and it frees us from political pressure to share code with Zen server. Yes, but we are grateful for the bridge chat, because actually we didn't have to fight management at all for using Haskell. Management, at least our direct management, actually really in favor of using static type languages, because it makes the project so much more reliable. We don't need to wait for the runtime for errors, for most of the errors. We can catch lots of them already. Yeah. So I talked a bit about the architecture. So basically, our Haskell programs are from one mold. That means they're sitting there, listening on dbus. Dbus is a messaging daemon that you may know from GNOME or KDE. And they listen, wait until something happens, until we want something from them. They get a request, do a short burst of activity, ask some other daemons to do something in dbus, or follow to the command line, or toggle some state in the database, and then they're done. We are very careful with the state, so we don't have much state lying around, and most of it goes to the database, so we can kill and restart as we want to, no problem. That is a paradigm we understand well how to do in Haskell, because we don't have to run out of memory. Normally we don't even do that. The laziness is not a problem. Performance isn't a problem. Basically, those types of daemons we have written in Ruby before, because actually the heavy lifting is done in the lower level bits written in Haskell, written in C mostly. And it works well for us, but I think it's kind of also a restriction. We should learn how to do more. Yeah, we have 4 people doing Haskell. We actually had a 5th one, but he's now in Taiwan. I learned Chinese. Actually, 3 of them do it because I love Haskell, and here's a triumph. We actually got Sahitia to learn Haskell to replace her daemon written in Ruby with Haskell. So she actually does it to get stuff done, and that works fairly well. She's still getting better and better at it, but the code is already better than the Ruby code we had. Way better. So I consider this a triumph. Even so, 4 people out of like 30 is not very much, so if you all quit tomorrow or get run over by a bus, it would be quite sad. On the upside, we try to keep the daemons small, so we can replace almost all the daemons within a few weeks, in case something goes wrong or the technology becomes unavailable, or just good habits to keep the daemons small. But anyway, I held an internal workshop to teach more people Haskell. Attention was voluntarily, so that's actually good that we had like 10 people at the beginning, later on a bit less, to attend that. That was in February, and we actually got to cover a bit of stuff. I say there are some stumbling blocks, but mostly basically it needs quite a lot of time to get people over it. Not so much that they say, no, I don't want to do it at all, it just takes time. Especially if you want to introduce monads. It makes quite a lot of sense to introduce lots and lots of examples, because if it just gives in the general definition, they ask, what can you do with it? And also you shouldn't use like the O monad, because the O monad is only a problem you have to solve in Haskell. In other languages, you just do it. So I tried to do parsing, because it's actually something where Haskell really shines, the same monad, but I think that was too advanced to try as an example. So yeah, if I do it next time, it will be better. Yeah, we have, Haskell has quite a lot of websites for us. So first, we don't have very much code in Haskell. Or we now have quite a bit of code, but it's not very much code. And the less code you have, the less stuff can go wrong. You can actually read the code, as opposed to if you have lots of code, or if you even wrote it in Perl. Hiring is way easier, because you just say, oh, we're doing Haskell, and lots of people actually want to work for you. As I said, we only have this one mold of Haskell programs so far, so we don't really care about speed. But I heard this, that's not in production. I played around with other stuff to get more I/O heavy workloads and try results. Package will tell you really helpful for finding stuff. So that actually makes up for quite a bit of lack of tool support that you have Google to look at. And yeah, parsing our config files and so on is really easy. We don't do quick check yet. A few downsides. So like I said, everything is in one mold. Don't do I/O heavy things in Haskell. Even so, the people seem to be quite happy to do that in C. Yeah, we had like that was back in 2010. We had to go through many contortions to make Open Embedded work with Haskell. With GHC that caused lots of collateral damage in the dependencies. I've only fixed it we fixed it so much that we don't need the workarounds, and I removed the workarounds only recently. Yeah, the hiring is easy, but the existing employees, if you want to get more of them to do Haskell, you need to invest quite a bit in it. If they're not wanting to use it on their own. So if they just want to get stuff done, it's possible, but it takes a while. As often people compare with their tool support could be better, and we can also complain about that. But I think there's lots of stuff coming out now, so it's more like for us we have to learn the tools how to do that. And a personal pet peeve of mine is if we had module syntax like an octamal, so we don't need first-class module or something, but just to have more than one module in a file, then like record syntax would become nicer, because you just prefix it and something with a dot. Like qualified info is what you can already do. Just in one file. Yeah. What we're not doing yet, but we're going to try out, is what I listed there, especially quick check, because it's really a shame that we don't use quick check. I use it privately, but we don't use it there. Those specific languages has been there's been lots and lots of talks about this at this year's ICFP. There's really should maybe look at it. And of course, how we have just streams of being used, because we actually want to disaggregate out on zero. That means break it up into smaller parts, and then running Haskell directly would be fun to do there. And the other stuff